Hello there. I'm going over one of the publicly available questions for AP Physics 1. This is a few response question. In this question, we're going to look at projectile motion, forces, acceleration, and all that good stuff. In the beginning, even though they're not asking us to draw a free body diagram as part of the question, I will still do that so we can assess what kind of accelerations or what kind of motion we are dealing with. Before anything else, let's consider what's going on. So we have two blocks. Both of them have mass m. And they're connected with a rope. The length of the rope is 4h. 3h along the table, and then 1h is hanging off. That makes block B of mass m distance h above the floor. And the surface of the table is smooth, therefore we assume that there is no friction of any kind. As soon as this contraption is allowed to move, it will move downward with acceleration. B will be accelerating downward, A will be accelerating to the right. So in terms of forces, there are three forces on block A. Gravity and normal balance each other out, and then force of tension. That force of tension equals force of tension on block B, and as far as block B goes, mg is greater than force of tension. Question A asks us to find the acceleration of block B. Acceleration of block B will equal the acceleration of block A. They're both going to be accelerating at the same rate. That is because they're connected by an unstretchable rope, and therefore they are moving equally. To get that, since we're talking about acceleration, we're going to remember Newton's second law that says mass times acceleration equals net force. And because this is a system of two blocks, we're going to write down Newton's second law as a system of equations. MA, and I'm thinking block B, should be equal to mg minus tension. Now block A, MA, is just tension. So as you could probably guess, we end up with 2ma equal forces of tension cancel each other out, and it just equals mg, from where A is half of g. A shortcut would be the force that is dragging it is mg, and it drags two masses. So therefore, A equals g over 2. So that answers question A. Acceleration of block B is just half of g. Question B is asking us to figure out how long it takes for block B to hit the ground. To do that, we're going to use the formula for displacement with a constant acceleration, because while it's falling, it has constant acceleration. So v initial t plus 1/2 acceleration t squared. This is 0 because we start from rest. This we found to be half of g. So that brings us to change in x, which is h in our case, equals 1/4 gt squared, from where t is going to be a root of 4h divided by g. So it's going to be 2 root of h divided by g. So that is the time that it takes for block B to hit the ground. 2 roots of h over g. C, they're asking us what kind of motion will block A have between the time of release to the moment when B hits the ground. We'll already discussed this. It will have this acceleration of half g. But then once block B hits the ground to the moment when block A flies off, the moment block B hits the ground, A stops accelerating. It will be moving with a constant velocity. What will that constant velocity be? Let's figure it out. We have two options. We know that V final equals acceleration times change in t. We found acceleration to be half of g. We found the time to be 2 root of h over g. 2's cancel. And if I plug g under the hood, it's going to be this, so we end up with root of just gh. Is that meters per second? Yes, it is, because it's meters per second squared times meters, so it's meters squared second squared. We get meters per second. What's the other option? We know that it's going to be displaced by the length h, and we know v final squared equals v initial squared plus 2 acceleration change in x. This is 0 because we start from rest. Then v final is going to be a root of 2. Acceleration we found to be g over 2. 2's cancel. And then change in x, I just said, is h. So we end up with root of gh. Either way, we're going to find that block A, from the moment block B hits the ground to the moment block A just flies off the end of the table, is going to be at a constant speed that equals root of gh. And then finally, once it flies off, how far from block B will block A end. They're asking us to find the distance, the difference in the landing spots. That is when we're going to start talking about a projectile motion. So something flies off with a horizontal speed root of gh. What is the change in x? So we know the speed with which it's going to fall. We know the height from which block A is falling. That's 2h. We're going to first find the change in t as the root of 4h divided by g. Remember, that's change in y equals 1/2 acceleration, change in t. Ends us at 2h to g is the time. Now v is gh, so therefore change in x is going to be 2 root of h divided by g multiplied by root of g times h. G's cancel, h squares, and therefore comes out of the square root as itself. So it's 2h. So the distance between the two landings, this right here, equals 2h. And I believe we answered all the questions. It's publicly available, so all is legal. If this was helpful, please like and subscribe, and I shall see you in another video. Thank you so much for watching.